Okay, welcome to all of you for this 40th CRE talk, the Collective for Reimagining Engineering and Innovation. We have been organizing a series of talks since almost last 1.5 years. And this is the 40th talk that we are doing, largely covering issues in engineering education, product design, and the research in these areas. Today, we have the pleasure of hosting Professor Kilian Gericke from the University of Rostock. Professor Kilian has been involved in the area of engineering design and product design. Currently, is the chair of product design at the University of Rostock. And his research interests cover areas like design research, the engineering design process, and related areas. He has been very actively working on the Pahl and Beitz related editions. And today he will speak to us more about the recent edition that has been worked out. And all of you will be aware, Pahl and Beitz is I would say a reference book in most of the institutions for product design and development. So it will be great to hear from Kilian in terms of how they have looked at the refreshment in this whole method, as well as the any new trends which are emerging from the rewriting this book for the latest edition. So with that, let me welcome Professor Kilian Gericke to share his presentation and speak to us. Thank you. Thank you, Kilian, for joining us.
Yeah, thank you very much for the invitation. It's an honor to present my work to this group here. And in this presentation, I will try to give an overview about two different areas of my work that merge in this presentation. The first is, of course, my work on the new edition of the book Pahl and Beitz, the systematic approach, which some of you might know. You refer to that as being widely used. And so this will be one part, but the second part of my work, which links nicely to that book, is concerned with the wider distribution and accessibility of design methods that we in our community create to better support engineering designers and engineering design students. And I will try to draw a picture that illustrates how Pahl and Beitz is one way of supporting us in our mission to making our research results more accessible and applicable. So the talk is called Transforming a Method Ecosystem, the new Pahl and Beitz. Design methods, this is the central part of the first section of this talk. Design methods are central to design practice, design research, and design education. Why do we use design methods? We use and propose design methods in order to support engineering designers. We aim to ultimately to improve design work, to create better outcomes, to be more efficient, or to achieve things that we cannot do without having any kind of structure. And most importantly, also in this group, as I understood you, we use design methods for design education to teach students new to the field how to approach new design tasks, how to bring the knowledge that they get in other areas, may it be mechanics, mathematics, or other fields, into application. When we talk about design methods in industry, we get a contradictory picture. And that's something that concerned me in the past somewhat, but where I have nowadays a more relaxed perspective onto it. When we talk about design methods used in industry, we can see whenever we talk, or when I talk with designers in industry, that they use methods. Methods are central for their design activities. However, designers do not really care about the names of the methods. They work in a structured way. They have learned at universities or from their colleagues. So they follow a systematic approach, and they apply the methods that we talk about in academia. And methods contribute to better designs, to innovation. So this is what we actually aim for, and that these are the benefits that we propose, and that people can get out of using design methods in practice. So this is the good news. However, this is something mostly design researchers complain about, is that much of the support that we as academics develop is not used in practice. And that's on the first view and first look at it, of course, not satisfactory. And this has been raised since the 80s again and again from different researchers, that the methods that we propose are not being used, not being effective. And from time to time, this comes up and is a concern. And I try to explain or give one explanation. It's only one explanation that might give some background, and also I try to provide a path forward and how we can overcome that. When we look at our activities as academics in the field of design research, we see that we create new design methods, new guidelines, new tools, and the number of methods is constantly growing. So if each dot is a method, we have many methods each year being published, being proposed to practitioners, to design educators. So academia develops a plethora of methods each year. However, and that's one part of the problem, as I try to outline today, most of these methods typically exist in isolation. So we see we publish a new method, but this method is being treated as an isolated support for an isolated activity. And that's, from my perspective, one part of the explanation why we might not be as successful as we would like to be as academics, aiming to support and devoting a lot of our time into supporting industry. But at the same time, as academics, especially as academics in the field of engineering design, when we talk about innovation quite often, we fall into a trap. Whenever we discuss and complain in academia about the lack of uptake of methods by industry, we assume that all of the methods that we carefully developed over time come into application. Of course, we have identified a need for better support. We propose, based on theory, based on other methods, a new approach that has some advantage to it. And we carefully evaluate that method. However, this method is still in competition with other methods that aim or propose to have the same benefits, which are already being implemented. So the transfer of the new methods, candidates that might really support practice, and the actual number of methods that being implemented and used in industry is a strong area, so it's a strong competition. And as researchers, we of course expect that our method will make it, but reality is often different. So this is the other part of the explanation, that we might have too high expectations in that competition to have an effect here. But the other part is also, as academics, as method developers, we develop these methods and we publish the methods. We display them at conferences or on other publications. But many of them are forgotten soon afterwards. So there is a gap, and that's also what Ken Wallace criticized in his contribution to the future of design methodology, a book published by Springer in 2011. I'll refer to that later again. So that we can treat these methods and how we publish them usually in academic outlets, so journals or conference proceedings, that these publications are kind of method zoos, where we display our latest methods and explain them, but they are treated in isolation, and readers can have a look at it, but they do not see them in their natural habitat. They see only the blueprint for using that method, but as I mentioned before, they see them only in isolation. And that's another part of the problem that we should carefully think about when proposing new methods and thinking about how we can bring them into application. While we see that methods typically, and that's part of most or mechanism of the way we publish most of the time, that they are isolated, we see at the same time that the need for integration in practice, but also in education, is growing. Just have a look at a typical application as a mechanical engineer, as a mechanical designer, when we talk about products that we design. This is a quite old mechanical gearbox. This used to be a typical application, a typical product being designed using methods being proposed in the 70s, 80s, purely mechanical, and you can come up with quite nice solutions. But we see in the present the design problems that practitioners are facing, and also our students are more and more facing, are way more interdisciplinary. We have a different type of complexity to it. New drivetrains of hybrid cars or purely electric cars go way beyond the mechanical parts, and this is contributing to that need for a stronger integration. And just anticipating the future, we see that being discussed at conferences, being discussed by politicians, but also by companies. We think of completely different scenarios how to enable mobility. So new mobility concepts for the future might go way beyond electric cars as we know them today. And so we can anticipate the need for integration, and the progress in technology is steadily growing. So this is something we also need to consider when talking about method development and also applications of methods. We might iterate in a way as researchers. We will propose methods for design activities which are in as such similar to what has been discussed 20 years ago, but nowadays they are discussed in a different context, talking about supporting the design of different products within different teams using different tools, and therefore there is a constant need for revisiting and improving methods and processes as a means for systematic design. So the need for integration will constantly grow. We see this not just for mobility systems, but we see that in many areas that we face as designers. Industry 4.0 or 5.0 is a good example for that. So industry is really reshaping itself by integrating new technologies. You are all familiar with that, but you see how this affects the systems in application, but also, of course, the designerly activity that brings forward these new solutions. And at the same time, especially here in Europe, I perceive that as a constantly named topic that we integrate already at bachelor's level with the students, but and we talk about that with politicians, is the need for more sustainable solutions, meaning that principles of circularity and sustainability will become commercial if they not already are, and they will become more imperative. So this is the next dimension to the constant change and the need for integration that we see. Meaning that in the end, for proposing solutions that address these challenges, we will need, of course, new technologies. And not just new technologies, but also new business models, and in order to implement these new solutions to some old user needs, but also, of course, some new societal and user needs and demands. And when we talk about new technologies and new business models, we have to talk about new processes, new design processes, product development processes, and new design methods that will assist designers in developing these new technologies which fit into completely new business models. And along with new processes and new methods, we will probably also need new tools in the future, knowing that most of the tools that we talk about in engineering design are computer-based tools. And at the moment, we, of course, discuss a lot how artificial intelligence will reshape the tools and at the same time integrate the integration with design methods in our daily activity. So the integration, the need is growing, and we see that the industry often explicitly states that they have a need for methods and tools that they can adopt and adapt to their individual context, so that these fit into their existing set of methods and their existing processes. This is a major concern often when I talk with companies talking about using new methods, new modeling approaches. They see the beauty and the advantage of following or of using that method, but they immediately start thinking of what would that mean if we integrate that in our processes? How does that link up? Good design managers start thinking not about the method in isolation, but that method interlinked with the existing set of methods that they currently use. And that's an important need. And when we talk about integration of methods, we have to think of different dimensions to that integration. The first is the integration into the design process. So we have a task, we start a design activity being performed by a group of designers with their individual prerequisites and considering the external conditions that we are working in. And this integration into the process, into the sequence of tasks in which these methods are being used, is the one part of integration. But at the same time, it's also about the integration with each other. So with other methods that are being used along the process that we talk about. So that's a challenge that we have to consider as design researchers, as method developers when proposing new methods, because ultimately that's one important decision to make as a designer, as a design manager, whether it's worth to integrate that method into the existing set, into the existing process, and what the implications are on the process and on other methods. So in order to do that and to ease that integration, we better propose or use a common vocabulary, or at least an explicit vocabulary, which allows the translation and the models, so that even though that we as academics might use a quite specific language, we have to carefully explain what we mean by that, so that users can link what we talk about to their internal company-specific terminology and can modify that. And we shouldn't care if they in the end call that method slightly different or do not care about the name at all, which sometimes worries some of the design researchers, so that they do not really identify their own method, that their baby that they developed being used in industry. I think that's not the important part. It's really about having an impact here. So integration is quite important, and that is the transition from what I called method zoos before. So these are individual isolated methods, moving from there into method ecosystems. So that need of integrating methods into the process and linking them with other methods, that's something that I refer to as a method ecosystem. A method ecosystem is understood as a set of methods that can coexist in a self-sustaining way. And this ecosystem here, based on definition by Tansley, stems from the from biology. So biological assemblage interacting with its associated physical environment and located in a specific place. So that adds that specific element so that the contextual placement of the system that we talk about. An ecosystem is not really generic. It's a quite specific set of interacting entities. And we talk here about design methods as being the entities that have to coexist. At this moment, we should start thinking of, okay, when we treat interlinked methods as ecosystems, we can distinguish here. And this is quite interesting. And might also give an explanation for that, the transfer and the challenges of transferring design methods into practice. First, we see method ecosystems in design practice. They evolved over time. And if they are working well, designers, design managers might be quite reluctant to change that. And only actively search for changes if there is a clear evidence that this might improve the performance, result in better designs, or because they just are really in serious trouble and cannot proceed as used when designing a new technology, designing a new system, and they need support to overcome that, that barrier. So these are regular ecosystem, design method ecosystem as we can see them in practice. They are quite specific to the companies that we look at. Each company, because of their specific products they design, have their individual process, design process, and an individual set of methods that is used along this process. And the second category of method ecosystems, and these are methods ecosystems that we use in design education for teaching our students. These I'm referring to as artificial ecosystems. And an engineering design course, a course on systematic product development, as I teach them here in Rostock, and I've taught them before in Luxembourg and Berlin, is informed by textbooks that we use, and obviously I'm using the approach first published by Pahl and Beitz. And this is a good example for a artificial method ecosystem. So a design methodology. For me, design methodology, I know there are different explanations of the term, but when I say design methodology, I refer to approaches published by, for example, Pahl and Beitz, by Wolfgang, by Pugh, or by Nigel Cross. These are good examples of design methodologies in engineering design. These design methodologies, they aim to provide guidance on how to organize the design process. So they give some structure, distinguishing the entire design process into phases and individual activities along the process that fit into these phases, and link these activities to particular outcomes. So that's one way, that's one important ingredient for teaching design students how to approach a new activity, how to start, what to do next. It's quite prescriptive, but it gives guidance to novice designers. These design methodologies at the same time, they provide a consistent set of methods. And here we talk about the artificial ecosystem. So they're carefully selected methods along the activities, along the design process that are capable of supporting these activities and that are also tested for a consistency along the process, so that we can use the method and the result of using that method, the way the information and new knowledge is being modeled, informs the subsequent activity and can be used for following the next method that is being proposed as a candidate to support a particular design activity. These design methodologies, they assume an idealized environment. And we'd have to do that in order to support design education. We cannot start with all the complications when talking about engineering design to novice designers. That would be too much, because we want to teach how to design. We do not want to teach every detail, every complication. We might do that quite late in the, or might do that later, maybe in a capstone project or in an extensive design project. But we will not start by doing that, of course. And that means that design methodologies, they do not and cannot describe a large variety of industrial contexts. They present the essence which is applicable across a wide range of different contexts. And a particular challenge when thinking of method ecosystem is different to method ecosystems that we see in design practice that evolved over time. Design methodologies can hardly be adopted by users because of the way they are published. I mean, we publish them as books, and this is not a dynamic set of contents. Users can interpret the methodology for themselves and, of course, modify it later on. But the methodology as being published remains unchanged, so that no one else can learn from the individual adaptation that someone else has done. This is different to a method ecosystem in a company. The knowledge about the methods, the consideration which method to use, and learnings from failed attempts of integrating other methods, this knowledge is shared, hopefully well shared in the team, but at least someone will know, and also the rationale for using a new method or not using a particular different method. So design methodologies, I treat them as artificial ecosystems. And also, just when we talk about a method ecosystem, so about design methodologies, here is a short statement on what we refer to as design methodology. A design methodology is an approach that combines methods, guidelines, and tools, each of which can exist individually, so thinking of isolated methods, but according to a process that organizes design activities and the use of the methods and the tools. The application of methods and guidelines and organization and performance of the process can be aided or enabled by the use of tools. So the methods are the connected elements that are proposed for supporting activities, and wherever useful, these can be supported by tools. But methods, design methodologies go beyond just the pure proposal of the methods and the tool and the process. They, of course, they propose concepts for efficient thinking and acting operations. So thinking in terms of functions, which is quite particular to the German design methodologies, and for example, Pahl and Beitz. Thinking in terms of problem solving and systems, thinking of systems approach that is being implemented in many of these design methodologies, especially in engineering design. And when we look across the field of design, we see design methodologies in different sectors. We see design methodologies like Hall and Hitchens in systems engineering. We see design methodologies in building design and architecture, mechanical engineering, named a few of them, Andreasen and Hein, another school. But we also see design methodologies being proposed in software design. So we see all these different design methodologies, artificial method ecosystems and design processes for these particular domains. And I will in this talk focus mainly on Pahl and Beitz as one example, widely used in Germany, but also beyond Germany, as the instance that I try to focus on. A critique that we see when we talk about design methodologies and about these artificial ecosystem is that these proposed systematic approaches is not the way real designers work. This was a statement by Ken Wallace. Ken Wallace was is the person why we do have an English translation of engineering design. So the book by Pahl and Beitz. He was using Pahl and Beitz in Cambridge during his teaching career, but he had, of course, a quite good critical stance and a position against that book. But no, that's wrong. It was not against the book. It was a critical reflection on how to use that book. So we need, of course, a design methodology. We need these processes, these simplifications in order to start teaching design. But at the same time, we should not create an impression and shape expectations with our design students that reality will be identical. Reality will be different, but they can learn from, they can build on what they see in that book and what they learned in our design courses, which were simplified versions. So what is the difference then when we say reality is not exactly as our artificial design method ecosystem? Real design processes have some important differences, and here is only a small selection, which I think is a good summary of quite strong characteristics. First, product development is not a purely sequential, predictable, or repeatable process. I think everyone who has designed will more or less agree that you can hardly repeat exactly the same process, and it would be boring. I mean, we want to create something new. How can we know the process in every detail without knowing the solution? So there must be something new to it, and that's part of the fun of learning along the design process. And something the process models can hardly depict is the iterative nature of design processes. Of course, we often see in the methodologies those back arrows which already indicate there might be some repetition, but you cannot explicitly say when will an iteration happen, when do you have to redo something, and for what reason. David Wynn gave a nice overview about the different types of iteration that we see in design processes. May it be for exploration solutions, may it be for convergence of a solution along a circular repetition of design activities, but on a different level of detail and maturity. May it be refining things for different scales of production, for example, starting from a one-off design to a serious production, you will do some refinement before you bring that into millions of batches that are being developed. But also iteration as negotiations between different departments, or purely repetition, or removing failures in your design. Particular and related phenomenon that we see when designing, which can be misunderstood as a not value-creating iteration, is that processes can easily be perceived or understood as co-evolution of problem and solution. And that's something we can hardly avoid, especially for novel design tasks that we approach. Where we have to come up with a proper problem description, and from there we start designing a first version of a solution. And by analyzing, that's here an exploration, well explained, By analyzing that prototype, we might understand better the design task, the problem that we wanted to address. So we refine our problem understanding, our problem description, based on the insights we gain from analyzing the prototype, from the solution. And with that refined understanding of the problem, we can move on. We create a new prototype, a new solution, refined version, and so on. And that might have to be repeated multiple times on different levels of maturity. And in the end, every product development process is unique. And this integrates, that's a summary and a description of what we have seen before. These before are the reasons for that. And of course, that means that processes need to be constantly monitored and revised. Revised is the key here. So we need to change our plans, need to adapt. And nowadays, when we talk about a modern approach to project management, we talk about agile project management, which I think has hard integrated this demand for constant refinement and monitoring. With the older descriptions of specific design methodologies, we came to findings like here by Herbert Birkhofer, also published in the book The Future of Design Methodology, where Ken Wallace also had a nice chapter in. He stated that classic design methodology has deficits in supporting current or even future development work that necessitate a substantial reformation. And that was in 2011, 2012, when this being distributed widely. It was well in the time when I started my postdoc work on design processes, which then ultimately informed and has been implemented in the latest edition of Pahl and Beitz. And I would now like to explain what we have done with the new book, where I think we addressed the majority of the challenges that I just outlined. So I think design methodology as such is capable of providing a proper support for design practitioners and students and design educators if we interpret them correctly and if we maintain them, keep them relevant for today's design challenges. So I will now start explaining what you can expect from the next edition of Pahl and Beitz. So the new Pahl and Beitz at the moment exists in its 9th edition in German language. So we published the latest edition in 2021. When I say we, I refer to the new editors. So it's me and it's Beate Bender. Beate Bender has done her PhD at the Technical University in Berlin. She was supervised by Professor Wolfgang Beitz, one of the originators of the book Pahl and Beitz, of course. Beate has worked at Bombardier Coachworks in Berlin. She was there responsible for complete realization of commuter train systems. So really starting from the tender management, by product management, to implementation on the production line. Currently, she is a full professor. She holds the chair of product development in Bochum at the Ruhr University in Germany. And my vita has some similarities. I did my PhD also at Technical University in Berlin. Especially, it was the same chair, but I wasn't supervised by Wolfgang Beitz, which passed away when I just was a first-year student. I did my PhD at the same chair, but supervised by Lucien Blessing. And Lucien Blessing was also one of the translators, together with Ken Wallace, of the Pahl and Beitz textbook into English. So you see, I and Beate as well, we both have always been exposed to Pahl and Beitz and that way of thinking and the whole methodology along our academic career, and for Beate also during her time at Bombardier. Myself, after completing my PhD in Berlin, I was then senior researcher in the Engineering Design and Methodology group in the University of Luxembourg. Together with Lucien, I worked there on parts of the book and on the VDI guideline, which I will also explain in a few minutes. Currently, I'm full professor here at the University of Rostock in the northern part of Germany, and I'm holding the chair of product development. So what's new about the new book? Why is it worth being mentioned here? To be honest, I gave a similar talk earlier this year at the Design Theory Special Interest Group workshop in Paris. And this was motivated by critique that came out of the community saying, Pahl and Beitz, that's pretty outdated, that's not relevant anymore. I mean, the English version is has been published, the last version in 2007. And I was not really embarrassed, but I was not happy about that statement. But then I realized, of course, how should people outside Germany know about the advancements with the book? I mean, the last edition is from 2021, and quite a bit has happened. The latest latest English edition, it's the third English edition, is based mostly on the fourth German edition, and the fourth German edition is from 1997. So there has happened quite a bit on the German edition, and we are about to translate the latest German edition into an English edition. We are quite far in that process. I don't want to say we will finish next year and having been published that book next year, but I hope so that 2025 marks the date for publishing the fourth English edition, which is based on the ninth German edition. We will see. But what is new? First, the book Pahl and Beitz now being an edited volume. That's one important change and was a necessary change because of the vast amount of topics that we address in that book. Neither Beate nor myself would claim that we are experts in every detail, in every subsection of the book. So we formed a team of authors from all major German technical universities. And beyond the German borders, we have also colleagues from Copenhagen, Tim McAloon and Daniela Pigosso, for example. They have a chapter on eco-design. And so we picked people that are familiar with Pahl and Beitz, and also Tim McAloon. He's quite well familiar with the book. And each colleague here on that map from Germany contributing to the book is using Pahl and Beitz for over a decade or 2 decades, 3 decades already. And so they are familiar with the book. And this is important when thinking of an artificial ecosystem. So these authors contribute to the book, but being familiar with that ecosystem so they could adopt their chapter, their contribution into that ecosystem and maintain the integrity of that ecosystem while evolving that ecosystem. That was something quite important, so that you can still use that book and combine elements of the book covering different design activities. Change the structure of the book. The book, over its different edition, has undergone some changes done by the previous authors. And we discussed that at length and try to harmonize the German edition in its structure with the structure that we see in the latest English edition, which was quite useful. And the structure, we have 5 different parts. So really starting with the fundamentals, then we organize the subsequent 3 parts of the book along the design process and the main phases. So task clarification, then conceptual design and embodiment design. And the book concludes then with a part that addresses methods and approaches that support accompanying processes of product development, such as project management, also being contributed from Copenhagen, from Josef Oehmann, and quality management, product documentation, engineering change management, and the like. So activities that do not just address a particular phase, but really cross phase activities. This integrates former contents, but also we have added along this structure new contents. An important element that addresses one of the challenges that I outlined before, so the critique, how the design process as being depicted in design methodologies, as being too rigid, too prescriptive, and not really matching reality, has been addressed in the latest VDI 22-21 guidelines. So the German Association of Engineers. So this is also, I think, a well-known guideline even outside Germany for organizing the design process. And Beate and myself, we also contributed heavily to the revision of that VDI guideline. So we were convinced that this is a good basis and fits nicely with the book Pahl and Beitz. And interestingly, also the old editions of Pahl and Beitz were always aligned with the VDI 22-21 guideline. So we repeated history here. So we first revisited the revised the VDI guideline and now integrated that into the book. By doing that, we considered new research findings in the field. We learned quite a bit about design processes, added more details and on the characteristics of design processes, updated the list of activities, and revised the process model. The process model you see here on the right-hand side is slightly differently organized, emphasizing more the repetitive nature of the design activity. And I will come back to the VDI guideline in a few seconds. What has changed else in the book? So we have quite a bit of new content. So we changed heavily the work or the content on product architecture. We have a complete new chapter on project management and on eco-design. A complete rewritten and extended chapter on embodiment design process. And we have new guidelines, for example, like design for fiber reinforced polymers that are integrated into the book, and always thinking of how to link that into the existing set of methods and into the language that is being used in the book in other chapters. And most of the chapters, almost every chapter has been revised, incorporating new research findings here. So this is what has changed, and I take only a very few minutes to explain the new ideas that are being implemented in the VDI 22-21 guideline as being quite central also to how the Pahl and Beitz textbook can be used and be interpreted. So the VDI proposes a framework of how to describe the design process, referring to a consistent set of design activities. However, it's slightly different that we do not emphasize the prescriptive perception that you could easily get from the older editions, where you really had a clear process model which was easily being interpreted as quite sequential. We try to avoid that because we know that design processes are not as sequential as these visual representations, these design process models might suggest. So we emphasize in the VDI guideline that the design process and the guideline needs to take into account the individual product development context. So what is the specific relevant factors in a particular organization, the specific technologies that are being used for creating new products, and also the individual group of designers that is being that is working together. We propose work phases that follow a certain logic, but that can hardly be directly being interpreted and transferred into a project plan. We emphasize that the proposed set of activities and the logic behind needs some adaptation. And this is, in the end, that's part of project management. But we emphasize that. This hasn't been done as explicitly in the past. So what we say is we propose a generic model of the product development process and say, for each project you would like to run, you need to do that adaptation. You need to detail that. You need to think of what adaptations are necessary. And we propose some things that people have to think about, that designers or design managers have to think about when thinking of adapting the proposed guideline to their individual context. First, something quite similar and obvious, but they should think of renaming the activities phases so that they match internal company terminology. We propose that designers should and should add relevant activities or omitting individual activities if that's not necessary for a specific product that they are designing. And these activities, of course, cannot cover all activities that are being relevant in a design process for each individual context. So we encourage them to break down these activities. We can break down them into details, but also we can break down them into a sequential repetition of the same activity along multiple phases. We can change the order if really, if that makes sense. We can think of parallel execution of activities, planned iteration of activities, and we can break down the entire process for different trades or suppliers that are working on sub-projects and needs to be synchronized along the process. And we show that this process adaptation is doable and that we can show that there's still the similarity for different context-specific projects and that they can still be linked to the generic product development process as being proposed in the VDI guideline. And that comes back to our method ecosystem, methods that are suitable for that generic product development process can usually also be implemented in specific adaptations in companies. And in the guideline, we give examples. We have 6 processes for different case studies. So these are automotive industry suppliers, automotive OEM, special machine development, electronic devices, and we included also one student design project as giving a reference. And we explain the contextual factors that distinguish these activities from the duration of the activities of multiple years to a few months, the production, whether this is done in-house or externally, the novelty that is expected, and also the batch size of these designs that are then being manufactured. All these are relevant factors having an effect on the specific implementation of the design process. And we then show the different design processes being based on the VDI guideline. So this is the latest change on the VDI, and we integrated that into Pahl and Beitz. And we hope that by doing these modifications, so having transformed the book into an edited volume, integrating a large team of experts, being familiar with the earlier editions of the book, help us to keeping the book Pahl and Beitz relevant for current practitioners, educators, and students. And by that, I would like to thank you for your attention and thank my co-authors on the book, on the VDI guideline, and members of the Design Process Special Interest Group of the Design Society. Thank you very much.
Thank you, Kilian. I'm sorry I had trouble logging in for some reason this morning. Your colleagues, a really enormous task, not just of revising Pahl and Beitz, but also contextualizing it in different industrial places. And I think that's very important for 2 reasons. One is to have a collective memory of how the method was used in different contexts and how it varies. And also the point you made about the distinction from the old Pahl and Beitz, which is a linear, often fixed set of methods, to this new space of alternate methods and the choice of methods being contextual to the product being designed and the cost and time frame. And I think this is an important part of how we use methods, and to make people understand that methods are not, the sequences of methods are not rigid, but they are contextual. So you really creating a localized theory of how the artifact should be produced. And that is something, I think, a very important point. And also, the last part I want to say is the historical evolution of methods, both in time and domains, is something we need to pay attention, in the sense that things are not static, but they are dynamic. So we need to figure out how to continuously configure and reconfigure methods. I think it was an excellent lecture. I really liked it, and I've seen it before, of course, but nevertheless, thank you very much. And I'll let other people ask questions, because I can always see you and ask you many questions. Yeah.
Thank you, Kilian. One quick question from my side is, do you see the convergence between, at a methodology level, between this kind of framework and the typical systems engineering framework, where methods are classified by different stages of problem solving and based on the different levels or types of expertise? Is there a convergence happening in that direction? That is one. Second is, when we talk about interdisciplinary products today, on the systems engineering side, you have had the development of the SysML type of modeling languages, which allow you to integrate both the engineering, software, and other dimensions. Is that something which is also covered as part of this discussion in this book?
Okay, two quite good questions. The first, the convergence with systems engineering, whether there is some convergence. I would say there has always been a co-evolution of both approaches. I mean, Pahl and Beitz also was heavily influenced by systems engineering approaches being published in the 60s, early 70s. Pahl and Beitz used what they've seen there, the systems thinking, how to decompose complex systems, and addressed that and interpreted that for engineering design. And I think we have seen evolutions in both domains at different scales. And because of the systems that we talk about now as engineering designers, I see a convergence in our domain. And we will see that this will be reflected in future editions in both areas. So what I mean is, the differences were not as big anytime, and the methodologies from systems engineering depends on it depends on how you interpret that, whether you see it as a fixed sequence or whether you say this is a recommendation. I think that's something that is to some extent up to the user and to the reader of these books. To be honest, I was always heavily surprised by the critique of the old Pahl and Beitz is quite sequential. I think it was 3 pages in total explicitating that you have to modify that. I think it's right from the 2nd edition onwards. It has always been in the book, but it was not in the picture. And people were just ignoring the text. And there was maybe not insufficient guideline on how to divert from that sequential depiction there. So that's something that we try to more explicitly articulate in that book here. For highly complex systems, I think there are different needs of how to synchronize teams across different grades. But at a smaller scale, you will see the same patterns. The second thing is regarding the use of modeling languages like SysML. We have no specific section of these regarding these modeling languages in the book, and this is something we definitely will think of how to do that in the future. The problem that we have with tool support and these structured languages is that, and we have as design researchers have to be careful here, who is driving, who is shaping future design processes? Is that done by tool vendors and the IT that's below, or that so informs these tools, or is it design researchers, design practitioners that articulating the need for tool support and for modeling approaches? At the moment, I see certain problems with SysML that force you into a tight frame how to execute certain activities because of the tool support that's doable. So this is something which is ongoing, and I expect huge changes in the future also in that area, which we then have to accept, integrate into the book.
Thank you.
I think there was a question in the chat. Ashish Diogare, yeah, go ahead if you want to. How do you find the role of AI in design of product and process? That's the question.
This is a highly relevant field, to be honest. I have no final answer here, but it's similar to what I said before about tool support. I think we have to carefully really study how the use of AI, how that aligns with the theories that we have. Will that affect the way we reason about design tasks? Will that affect teams collaborate? The dynamics of interacting with an AI tool is different from the way you interact with a design team. So I do not care so much about narrow intelligence, ANI, but about general intelligence. If that may come, how will that affect? That's something we carefully have to investigate, because I think it will affect the process. It will affect the way we design, and we have to prepare for that here, because otherwise the tools and the capabilities of the tools will force us to follow certain activities and might not be the most the smartest way of doing.
Also, I find that your explicit focus on product architecture is a good thing, because that is something in the regular traditional books you don't find much attention being given to the product architecture, which is very relevant today when you talk about not only product but product service systems. Having some very specific attention to the defining the product architecture is a good move. That is something will be useful.
Yeah, thank you for the feedback.
Thank you very much for giving this lecture. And we usually, we get anywhere from 10 to 15 people, sometimes to 50 people. So we will put it up in the web. And in fact, I had asked the Design Society to see whether I can put it up in the web there and invite more people to come and give talks. We already have 40 talks. My goal is to get hopefully 100 talks of all of our colleagues, because this is an open forum, and it's not, we don't have such a thing at the moment in the Design Society to get people from all over the place. So I'm hoping we can make it into a Design Society.
It's under development. So the design exchange, the Design Society exchange nowadays, it's under development. And as far as I know, it's also discussed how to revise the website entirely. So maybe that's the right time to express the idea of doing that and to integrate that as a requirement for the redesign of the website then.
Yeah, I have mentioned it to Ula and others. I think they took it up, going to take it up in the board meeting. Anyway, thank you very much. And if you think anybody else would be a good person to talk from Europe, I already had Gaetano, I already had a few other people, Frido and Pascal is supposed to give some time. And so if you can point me to some people you think I should include in this series, I would be more than happy.
I will think about that and will let you know via email then.
Okay. Thanks, Kilian. You have a good afternoon and evening.
Thank you.
Thank you. Bye-bye.
Bye.